Dear students, now we are going to see the subject Signals and Systems, and the course code is EC3354. The topic under the course is Fourier Series. So on completion of the Fourier series, the students can able to apply the Fourier series on continuous time signals. Fourier series, that is the Fourier representation of continuous time periodic signal, which can be used to perform the frequency domain analysis of signals, in which one can study the various frequency components present in the signal, magnitude and phase spectrum of various frequency component. Condition for existence of Fourier series. The Fourier series exists only if the following Dirichlet conditions are satisfied. The signal x of t must be single valued function. The signal x of t must possess only a finite number of discontinuous in the period capital T. The signal must have a finite number of maxima and minima in the period capital T. X of t must be absolutely integrable. That means integral 0 to t, x of t into dt value should be less than infinity. Types of Fourier series. There are three types of Fourier series, that are trigonometric Fourier series, exponential Fourier series and cosine Fourier series. Trigonometric Fourier series. The trigonometric form of Fourier series of a periodic signal x of t with the fundamental period capital T is defined as x of t equal to a naught plus summation n equal to 1 to infinity a n cos n omega naught t plus summation n equal to 1 to infinity b n sin n omega naught t. Here a naught, a n and b n are the coefficients of trigonometric Fourier series, and a naught, a n and b n's are evaluated like this. So the a naught is equal to 1 by t integral t naught to t naught plus fundamental period capital T x of t into dt. A n is equal to 2 by t integral t naught to t naught plus capital T x of t cos n omega naught t into dt. b n is equal to 2 by t integral t naught to capital T naught plus capital T x of t sin n omega naught t into dt. Exponential Fourier series. The exponential form of Fourier series of a periodic signal x of t with period t is defined as x of t equal to summation n equal to minus infinity to infinity cn e power jn omega naught t. Fourier coefficient cn can be evaluated using the following formula. Cn equal to 1 by t integral minus t by 2 to t by 2 x of t e power minus jn omega naught t into dt. Cosine Fourier series. The cosine representation of x of t is x of t equal to a naught plus summation n equal to 1 to infinity a n cos of n omega naught t plus theta n. Here the capital A naught is the DC component and capital A n is harmonic amplitude or the spectral amplitude or the nth harmonic component. Theta n is the phase coefficient or phase angle or the spectral angle. The exponential Fourier series of a coefficient x of t equal to sin omega t. So we are going to find the exponential Fourier the coefficient of the signal x of t equal to sin omega t. So x of t equal to sin omega t, x of t, expand the sin omega t in terms of exponential form, e power j omega t minus e power minus j omega t by 2j. Here the n value ranges from minus infinity to infinity. If we substitute a n is a naught is equal to 0, because a naught is equal to e power 0, that value is 1. There is no more component was there, so a naught is equal to 0. a1 is equal to 1 by 2j, then a suffix minus 1 is the n value is minus 1, then its amplitude is minus 1 by 2j. So ak is equal to 0, that means the modulus of k value should be greater than 1. Determine the Fourier series of the following triangular pulse signal. So the triangular pulse has an amplitude a and its fundamental period is t. Here the triangle function, first we are going to determine the signal x of t using the equation of straight line, that is y minus y1 by y2 minus y1 equal to x minus x1 by x2 minus x1. Here x1 is 0, x1 value is 0 and y1 value is 0 and x2 value is t, y2 value is a. So here we are considering 2 points P and Q. So these are the 2 points of the triangular signal, one at the origin and the another signal is at the end of the fundamental period capital T. Now substitute the x1, y1, x value is equal to capital T and y value is equal to x of t in the equation, and simplify this, we are getting x of t equal to a t by capital T. Now we are going to evaluate the A0 value. A0 formula is this 1 by capital T integral 0 to t x of t into dt. That means the integration is performed over a one fundamental period. So capital T is the fundamental period of the signal given. So 1 by t integral 0 to t x of t, substitute the x of t, that is at by t into dt. So capital T is a constant, so you keep it outside. 1 by t square, and a is also a constant, so you keep it outside. Then integrate t with respect to t, so you are getting t square by 2. The power limit is from 0 to t. Now you substitute the limits, so a by t square into t square by 2 minus 0. Simplify this, we are getting a0 is equal to a by 2. Then evaluation of an formula is 2 by t integral 0 to t x of t cos n omega naught t into dt, which is equal to 2 by t integral 0 to t a t divided by capital T cos n omega naught t into dt. Now keep the constant outside, so 2a by t square integral 0 to t into cos n omega naught t into dt. So this is of the form u v dash. So u v dash can be written as u v minus integral v du. That is, here t is the v value and v dash is equal to cos n omega naught t. So 2a by t square t into sine of v dash, integration of v dash gives the v. Its value is integration of cos n omega naught t is sine n omega naught t divided by n omega naught minus integral sine n omega naught t divided by n omega naught into dt. The limit is 0 to t. 2a by t square is constant, and again integrate the second term. The first term remains same, t into sine n omega naught t by n omega naught minus integration of sine n omega naught t is minus cos n omega naught t by n omega naught the whole square. Limit is 0 to t. Substitute the integration limits. 2a by t square, upper limit is simplify this, then we substitute the limit t into sine n, substitute the omega value. Omega is equal to 2 pi by capital T. So sine of n 2 pi by capital T into t divided by n 2 pi by capital T. So minus into minus becomes plus cos n 2 pi by capital T divided by n 2 pi by capital T the whole square, and the limit is 0 to t. So which gives 2a by t square. Substitute the limits, so capital T sin n 2 pi by capital T into t divided by n 2 pi by t plus cos n 2 pi by t into capital T divided by n 2 pi by t the whole square minus, so if t is 0, the entire term is 0, so minus cos 0 is 1, so 1 by n 2 pi by t the whole square. So on simplification of this, we are getting t get cancelled in the sign terms, as well as in the denominator t comes to the numerator. So 2a by t square, this term is t square sin n 2 pi divided by 2 pi n plus t square is cos n 2 pi divided by n 2 pi the whole square minus n t square by n 2 pi square. So which is equal to sin n 2 pi value is 0. So 2a by t square plus t 0 plus t square cos n 2 pi value is 1, t square by n 2 pi the whole square minus t square by n 2 pi the whole square. On simplification of this, the two terms get cancelled, so an is equal to 0. Evaluation of bn. The formula used to find the bn is equal to 2 by t integral 0 to t x of t sin n omega naught t into dt. So substitute the x of t in this formula. So 2 by t integral 0 to t at sin n omega naught t into dt, that is equal to 2a by t square integral 0 to t at sin n omega naught t divided into dt. So here the constants are outside and this is also of the form u v dash. So integrate this. 2a by t square is constant. So t into integration of sin n omega naught t is minus cos n omega naught t by n omega naught minus integral minus cos n omega naught t by n omega naught into dt. Limit is 0 to t. That is equal to 2a by t square into t into minus cos n omega naught t by n omega naught. Integration minus into minus become plus. Integration of cos n omega naught t is sin n omega naught t by n square omega naught square, and the limit is 0 to t. Now substitute the omega value. Omega is equal to 2 pi by capital T. So 2a by t square is constant. Then minus t cos n 2 pi by t into t by n 2 pi by t plus sin n 2 pi by t into t divided by n square 4 pi square by t square. Limit is 0 to t. Substitute the integration limit. 2a by t square minus t cos n 2 pi and cancel the terms. Substitute the limits and we simplified. So cos n 2 pi by n 2 pi by t, sin n 2 pi by n square 4 pi square by t square. So if we substitute t value is 0 here, the entire term is 0, sin 0 is 0. So that term get cancelled. So that is represented by plus 0. Now this denominator t goes to the numerator. So the term becomes 2a by t square minus t square cos n 2 pi by 2n pi plus t square sin n 2 pi by 4n square pi square. Sin n 2 pi value is 0, cos n 2 pi value is 1. So the term becomes t square and t square get cancelled, 2 and 2 get cancelled. So bn is equal to a divided by minus a divided by n pi. So here if we substitute the n value equal to 1 to infinity, we are getting, if n is equal to 1, that is our b1 term. So minus a by pi. If n is equal to 2, we are getting b2 is equal to minus a by 2 pi. It's going on. So substitute the trigonometric Fourier coefficients in the formula. X of t equal to a naught plus summation n equal to 1 to infinity a n cos n omega naught t plus summation n equal to 1 to infinity b n sin n omega naught t. Here the x of t is equal to substitute the a naught, a n and b n value in x of t. So x of t equal to a by 2 plus b1 sin omega naught t plus b2 sin 2 omega naught t plus b3 sin 3 omega naught t. Substitute the b1, b2 and b3 value, are getting the trigonometric coefficient. Here the an value is 0, so the term is removed. A quiz question: which are the Fourier coefficient of the following? Here the a naught, a n and b n are the trigonometric Fourier coefficients. Thank you for watching.